Okay, guys, recording is in progress. Let's start session 2. Again, usually if we do a good amount of work, let you guys go early. If we finish a good amount of work by 9:30, we can call it off, but let's see how it goes. Okay. All right, so now we come to something very interesting. Order of operations. Again, if you look at the section in your module manual, it's very long, very drawn out, a good amount of pages. All it is summarizing things one by one to get to board mass. So we can just skip ahead and go there. Everyone knows board mass, you've seen it a million times. But there's a few things here which I'm always surprised when I ask everybody to tell me what the letters stand for, what they represent. People forget things, right? And that's okay. So even I forgot some things the first time. Let's just check, right? If you don't know these things, don't feel bad. It's okay. Okay, so we'll start with the B. Everyone knows what the B stands for, right? Brackets, right? It stands for brackets. So I'll just put here brackets. So brackets covers, they use a lot of words to represent different types of brackets. Your brackets, parentheses, whatever, right? All these things. But there's another thing that falls under the B, which is not a bracket. Does anyone know what that thing is? Again, if you don't know, it's okay. Don't feel bad. It's one of those things that once you know it, you can't unknow it. So brackets covers two things. It covers brackets, of course, and fraction bars, right? Fraction bars. So I'm not going to show you guys brackets because you know what brackets look like. A fraction bar is something like 2 plus 1 over 5 plus 2, for example. Because the fraction bar is like a separator, right? You look at the top first, 2 plus 1, you deal with that, then you come to the bottom, you deal with that. Okay, you can do it in any order. You can do this first and then that. Bottom first, then the top, then bottom, doesn't matter. The point is the fraction bar is like a separator. It's like a bracket. You know, you deal with the top, you apply board mass to the top completely, and when you deal with the bottom, it's a separate thing to which you apply board mass completely. Right, a fraction bar. So that's an important one. That's the B. The O, this one is usually the biggest disaster of all. What does O stand for? Anybody knows? Off, right? Off is not a very descriptive word though. Anyone knows what the off talks about here? Someone said the right thing. Exponents. Exponents, right? That's the word I'm looking for. That's one of the things, exponents. Okay, excellent. We have a good start. Exponents, anything else that the O covers? Anything else? Anyone wants to Google it and act like they knew the answer all along? Okay. Okay, think about the opposite of exponents. You guys know it. Someone is saying the word, I can hear it softly. Roots, right? That's the word. So exponents and roots. So exponents and roots are opposites of one another. They're kind of like the same process, but in different directions. So for example, if I had 2 squared is equal to 4, that's what an exponent does. It takes a 2, squares it, and gives you a 4. If I take a 4 and square root it, I get back to 2. Right? So opposite processes. One undoes the other. Right? Some people might be looking at this and saying, technically the answer to this is plus minus 2. Yes, that's correct. That is true. But for some reason in these notes, I think it's an American syllabus or whatever, something is a little bit different than the way we do things because they talk about a thing called a principal square root. So when you take a square root of 4, we take only the positive answer, which is 2. That's what they call the principal square root. It's a bit weird, but that's how they do things in the notes. So we have to be consistent with that. Okay, so that's the O. The rest, everyone knows it. AS, everyone knows it's division, multiplication, addition, subtraction. But there's just one more nuance here that we need to be careful about. Can anyone tell me what that is? Any more things to be aware of in quadrants? Okay, let me just take away the misery right now and tell you guys. The D, M, the A, the S, these things are grouped together in a way that means when you're working on an expression, usually you look at the expression left to right, and whatever you come across, you go in the order of BODMAS, right? But when you come here, whichever one of these you come across first, that's the one you do first. So the order can change for the D, the M, and also for the A and the S, the order can change. All right, so maybe best to explain with an example. Suppose I had 2 times 3 divided by 1, whatever, right? Something like this. According to BODMAS, okay, let me add a 1 plus here. According to BODMAS, when we work on this, we start left and go toward the right. Whatever we meet first, we check according to the order of BODMAS, whether we operate with that first or we skip it. All right, so first we look for brackets, left to right, I don't see any brackets. We look for exponents or roots, I don't see anything, looking left to right. Then we look for division or multiplication, right? Again, the order doesn't matter here. So left to right, what do I come across first? Multiplication, right? That's the first thing. Even though that's under division, we still do that first. That's the point I'm making here. So 2 times 3, we operate that first, and then after that, we do the divided by 1. Even though division by 1 doesn't change anything, I'm just to make the point. Okay, did I confuse anybody there? Yes, it is a bit of a confusing thing. Okay, so let's see. We have examples here, I think. Yeah, we'll try a few examples. Few examples should help. Let me just see. Yeah, okay. Also, I did upload the lecture notes to ARC. If you want to download those, you can do that as well. Give you guys about 5 minutes, should be enough time. Let's see. You're an increment of the 16. Okay, guys, I'm doing number 2 on the board. There's no numbers here, but second one. Okay, so let's just make sure we all understand how to apply board mass. If you can do it for one, you can do it for anyone. Okay, so if I start looking at the expression left to right, we start with the 60, left to right, and we check each thing here. So B, there's no brackets there, right? So that's okay, we ignore that. O, there's no exponents or square roots, so we ignore that. Then we check these two together, division or multiplication. So do we come across any of those from left to right? We meet one here, right? 30 divided by 3. Again, division, multiplication, any of those two. Whichever we meet first, we do that first. So the 30 divided by 3, we simplify that. Right, that's going to give us a 10 here. We still have a multiplied by 5 after that, plus 7. Okay. All right, so then the next thing we have to look for, again, left to right, what do we meet first? We're still on the division multiplication. We haven't passed that yet. Left to right, we still find a multiplication here, so we have to simplify that. Everything else remains as it is. 60 minus 50 plus 7. Okay, now from the addition, subtraction, same principle applies. Left to right, whatever we meet first, we do first. All right, so the 60 minus 50 is the first thing we meet. We do that first, so that gives us 10 plus 7. Now that's the only thing left, so that's just 17. Okay, you guys all good with that? Okay. All right, so do you guys think you'd be in university doing board maths? Okay, we'll go through the stuff as quick as we can. Learning Unit 1 should be done soon. Okay, anyone wants me to do any of the last 2 examples? Yes, both of them. Okay, all right, let's do it. All right, so again, my quick maths fails sometimes, so if I mess something up, just correct me. If you see a mistake, just correct me. Okay, so here we have a bracket, so we got to work in the bracket first. Let me just start on this side actually. Work in the bracket, so 900 divided by, now in the bracket, we apply board mass separately to everything within the bracket. So in the bracket, we meet a multiplication. That's first in the order of board mass, so we do that first. So we get a 6 plus 3 times 8 gives us 8, 16, 24 minus 10. Okay, and we still need to finish the bracket, right? We can't ignore the bracket, so we finish that. Everything else remains the same. 6 plus 24 gives us 30 minus 10. At this point, we don't have to write the bracket anymore because it's just one thing. If you want to, you can, but it doesn't change anything, right? So you can write it or you don't have to. I'm going to choose to take it out. Okay, then the next thing is we have division and subtraction. Obviously, division is first in board mass, so we do that first. 900 divided by 30, 330, right? So that should be 30 minus 10. That's the only thing left now, subtraction. So from that, we just get 20. Okay. All right. If anyone's answer is different, let me know, because it's more likely I made a mistake than you. Okay, now here we have a bracket within a bracket. So everything remains the same and we work within the brackets. So within the first bracket, we have nothing to do here yet because there's an inner bracket. So we start working from the inside outwards. So first we work with this bracket. Right? That's the innermost bracket. Everything else remains the same. So I'll leave everything else as is. 20 minus 3 times 4 minus this bracket here is just going to give us 6. And divided by 2 doesn't change, right? Now we can simplify further within the bracket. 4 minus 3, what can we do here? There's a multiplication, so we must do that. Everything else remains the same. So here we get a 4, 8, 12 minus 6 divided by 2. Right, all I did is the multiplication, nothing else. How's my space here? I'm still good, I think. Okay, so in the bracket now, there's only subtraction. So 20 minus 12, 12 minus 6. Okay, so you can do this all in one step, right? This subtraction, you can subtract both these in one step. If you want to be careful, you can show it step by step. I feel like I messed something up already, did I? Good, it's fine. Okay, 20 minus 12 minus 6. Anyone can do quick maths there? 8. 2. Everything is 2. Okay. 10 minus 12 minus 6. Yeah, right. So everything is 2. You guys fine with that? You can do it step by step if you want to. There's a divided by 2 here. Okay. So now we have, I'm going to just write this so you guys can see I'm rewriting this as 3 times 2 divided by 2 because that's what it means. The bracket means multiplied by, right? If you see something on the outside of a bracket, that just means multiplied by. So that and that are the same, right? If I lose anybody there, let me know. Okay, let me bring that up. And then from here, again, left to right, we come across multiplication first. So we sort that out. That's 6 divided by 2. Then we come across division. So that's 4 minus 3, which is just 1. Okay, you guys all got 1? Okay. Anyone got 1? Hands up if you got 1. I can see. Okay. Perfect. Perfect. Okay. All right. And if you don't like board mass, there's also this other thing, PEMDAS, how we say it. Right. Some of you guys might have learned this in high school. My high school career was a very long time ago, so we use board mass. But it's the same thing. Whichever one you like, you can use. PEMDAS is exactly the same thing. They use this weird acronym here. Please excuse my dear Aunt Shally. I don't know if you guys heard about this. So whatever, right? If you like to use this, you can use it. Some people say, please excuse my dumb Aunt Shally. That's also another way to remember it. I'm on the recording saying that now, but anyway, okay. So very quickly, I'm going to define 2 things here from this slide, expressions and equations. We don't have to read the story here. I'm just going to define it with an example. The story is there for you guys to read if you want to. So an expression is, I mean, there's an example here, half base times height is an expression. That's a formula for area of a triangle. Anything which is a combination of numbers, variables, and mathematical operations is an expression. So it could be anything, even something like 2 squared plus 5 divided by 8 divided by 2, whatever, right? This is an expression. Okay, even if I put variables here, if I said 5x, for example, that's still an expression, right? if I took this and said equal to 2x, right? Now we come to the difference between expression and equation. This entire thing is an equation because of the equals to sign. But this on top here, let me change the color for this. This right here is an expression. This right here is an expression. When I combine them with an equals to sign, the entire thing is an equation. But this by itself is an expression. This by itself is an expression. So if you see something like this without an equals to sign, it's just an expression. Once you include an equals to sign, it becomes an equation. Equations combine expressions. Okay, is that okay for everyone? Good. Okay. All right. Questions? And I guess we should also define a variable and a constant. Okay, you guys know what a variable is? Right? It's just a letter representing a number which is possibly changing. Right? So usually we use X in algebra, X, Y, Z. A letter to represent a number which is possibly changing, an undefined value. I shouldn't say undefined, that's a scary word to use. It's just a value which is changing, it could be changing. Okay. Constant is something which is not changing. So in this example, 24 minus X, can you identify the constant here? 24, the variable, X, perfect, right? Simple as that. Okay, substitution and evaluation. For this, I'll just do one example to show you guys the difference between the two if you don't know it already. In this example here, evaluate 24 minus X when X is equal to 3. We have to first substitute, then evaluate. The substitution part is when I say 24 minus X is equal to 24 minus 3. Right? All I've done is substitute the given value into the expression, right? That's substitution. So I'll say here, this is substitution. Finding an answer to this equal to 21, that's evaluation. Subtle difference between the two, but just take note of that. Okay. Make sense to you guys? Okay. All right. And there's more examples at the bottom for you guys to try. If you have trouble with those, let me know. Section 3.3, 3.4, 3.5 in the module manual. Let's see what these are. Yeah, so they're very straightforward. You guys can read them in your own time, but you probably don't need to, right? Because adding real numbers, if you did not know how to add numbers, you couldn't have gotten this far. You can't learn odd math without knowing how to add and subtract. So I'm not sure why the order is like this. But anyway, you can read it at home if you want to. Don't have to though. You really don't have to. Okay, resultant signs and multiplying different signs together. You guys know the story by now. Positive times positive gives you positive. Positive times negative gives you negative. I'll just give you one example for each one to show you guys. I'll use any random number. A positive number times a positive number gives you a positive number. All right, all good with that. Negative number times a negative number gives you a positive number. And any other combination will give you a negative number. Okay, you guys have all seen this kind of thing before? Yeah, okay. And also take note that it works exactly the same for division. So if it does not multiply, if it was divided, the signs combine in the same ways. Okay. Yeah, sorry, someone corrected me there. -6 at the bottom, right? Thank you. Okay. So guys, please spot these things because I do them often. Just take note. Okay, thank you. 9:25, you guys still surviving? Some no's. Okay, we're going downhill slowly. So we'll try and finish as quickly as we can. If we can get the slider to move at least halfway from the top, so let's see, up there. It looks approximately up. If we can get somewhere there, we should be good. Right? And I'm sure we can get there. There's probably like 2 or 3 more slides. Okay, 2 terms we need to remember. Additive identity and multiplicative identity. Right? These are fancy words for 0 and 1. Right? We know what 0 is, we know what 1 is. Unfortunately, we have to remember stupid terms, but we have to remember them. We use the word additive identity because usually identity refers to something that when you use that in an operation, it doesn't change anything. So 0 is additive identity because it doesn't change anything under addition. You can add 0 to something and it doesn't change that thing. Right? There's an example given at the side there. A plus 0 is just A. So A is additive identity because it doesn't change anything under addition. Same logic, 1 is the multiplicative identity because 1 does not change anything under multiplication. Right? Again, if you don't know how to remember what the logic is, just memorize these words, right? That's all we need to know. Okay. Additive inverse, multiplicative inverse, again, just things we have to know. The additive inverse is just the negative of a number. I'm not sure why we need the word at all. Right? If I tell you 7, for example, what's the additive inverse of 7? The answer is negative 7. Right? Simple as that. So let's just, okay, it's not good. Let's just write that so we remember it. For 7, the answer is negative 7. Multiplicative inverse, also known as a quotient, you guys probably heard of a quotient before, is just you can think of it as the inverse of the number or the number 1 divided by the number, right? So for example, if I tell you 8, what is the multiplicative inverse of 8? The answer is 1 over 8, right? If I gave you 3 over 2, what is the multiplicative inverse of 3 over 2? It's just 2 over 3, right? So you just flip the thing. And to be clearer with the 8, you can write 8 as 8 over 1, so you can see the same theme happens. 8 over 1, the multiplicative inverse is 1 over 8. So you see the same pattern is happening. Just flip the thing. You flip the fraction, basically. Okay, I can see we're struggling, guys. Let's just try and finish this one slide at least. One more slide. Okay. 2 examples. 2 very quick examples here. What is the additive inverse of 8? Can anyone tell me what it is? Negative 8, right? And prove it. How do we prove that? Right? That's one way. We can just say, believe me, right? That's one way. Another way is to just show, add the original number to the additive inverse and check if you get 0. If you get 0, then we're on the right track. So I take 8, add it to minus 8. This is the proof. That gives me 8 minus 8, which is just 0. If you come up with a 0 at the end, you've proven it. Okay, so multiplicative inverse of 8. Example 2, what is the multiplicative inverse of 8? Anybody? 1 over 8, thank you. 1 over 8. So how do you prove that? Similar idea, you multiply the two numbers together. Multiply 8 by 1 over 8, which is equal to 8 over 8, which is just 1. If you get 1 as output, then you've proven it. Okay. So for multiplicative inverse, to prove it, you need 1 as an answer. For additive inverse, you need 0 as an answer. Okay. You guys think we can manage one last example and then I'll let you guys go? Okay, perfect. Last example. So the principle here is that dividing is the same as multiplying by the reciprocal. I don't know why we're using a different word here. Multiplicative inverse, you can use that word. So for example, 2 divided by 4 over 3. Division looks a bit sinister sometimes, so it's better to write multiplication. 2 divided by 4 over 3 is the same as 2 multiplied by 3 over 4. You change the division to multiplication and invert the second fraction. Always remember, invert the second fraction, not the first. Some people invert the first, that's wrong. You'll get that wrong. Right, so here multiplication is easy, right? With fractions, it's just, you can write this as 2 over 1 times 3 over 4. You don't need a common denominator, any of those weird tricks. You just need to multiply the top together, the 2 and the 3, and the bottom, the 1 and the 4. Here you will get 6, here you will get 4. You can simplify that further if you like. Why does that happen? 3 over 2. Okay. Just bear with me, guys. I just want to show you, if it was the other way around, 4 over 3 divided by 2. If it was this way around, then the way you do this is 4 over 3. You can write it as 2 over 1, firstly, in case you need to do. You don't have to do that step if you want to. This is the same as 4 over 3 times a half. Flip the second fraction. Change division to multiplication, flip the second fraction. Okay. You guys okay to stop there? Yes. Okay. Questions before we leave? All good. Okay, then guys, I'll see you next time. Thanks for your attention. And yeah, see you guys next time.